In this video, we're talking about molar mass, which is definitely different than a mass of something that we've been talking about previously called grams, which you would, step on your scale, and this would give you something in grams. This is different because this is molar mass. So this is relating the number of moles to the mass in grams. So a scale is really great because we can measure something in grams, but how many moles is that? Well, that's important for determining ratios for chemical reactions. But we don't have a tool in lab that's going to tell us the number of moles. So that's where molar mass comes in. So in this video, we're talking about calculating the molar mass, and the tool that we're going to be using for that is our periodic table of the elements. So it's something that, any good chemist keeps with them, or, is easily Googleable. And then we're going to convert grams to moles and moles to grams. So remembering that grams is something we can measure in a lab, and moles is something that we're going to figure out for chemical reactions. Okay, so starting with molar mass. So our molar mass is going to have units of grams per mole, and it's always per 1 mole. The number of grams changes, and so basically the molar mass is going to be unique and a constant for each chemical formula. Each chemical formula has one specific molar mass, and that's going to tell us how many grams are present in 1 mole of whatever formula or whatever compound we have. Okay, and so that's really how we're going to use this ratio. And so some people like to do this via what I like to call the triangle method. So you can kind of solve this. If you're given 2 of any one of these, just like for density, you can solve for the third. So our molar mass, our grams, and our moles, just like that. So if you want to solve for grams, you're going to multiply the molar mass times the moles. And if you want to solve for the moles, that's going to be the grams over the molar mass. Okay, so let's go ahead and do some practice calculations on how do we calculate this molar mass, or the amount of grams that are present in 1 mole. So I mentioned before that we're using our periodic table of the elements, so make sure you have that with you. And let's do 2 practice compounds, NH4 2S. This is known as ammonium sulfide, also the main component of stink bombs, because whenever you're talking about moles, it gets a little stinky, so we might as well do that. And the other compound is good old-fashioned H2O, or water as I like to call it. Okay, so how do we determine the molar mass? Well, first we determine the number of each type of atom that there is, and then we just add them all up. So we're going to look at the atomic masses on our periodic tables and add up the mass of each atom in our formula. So let's start with the tough one, the NH4 So or ammonium sulfide rather. So we're going to take this 2 and distribute it to every part inside the parentheses. So really what we have here is we have 2 N's. We're going to have 8 H's because 2 times 4 is 8. And we're going to have 1 sulfide because that's outside. There's no number here, so we know that that's definitely a 1. So whatever our value for atomic mass is on our periodic table for nitrogen, we're going to multiply that by 2 because there's 2 nitrogens in this formula. For H, same thing, and we're going to multiply that by 8 because there's 8 H's in this formula. And for sulfur, just 1. There's only 1. So nitrogen its atomic mass is 14.01. We're going to multiply that by 2. Hydrogen its atomic mass is 1.01. We're going to multiply that by 8. And sulfur, its atomic mass on the periodic table is 32.07. And we're going to multiply that by 1. Anything times 1 is itself. After we figured each one of those out, so this is going to be, for nitrogen, it's 28.02. For hydrogen, 28.02 plus the hydrogen, which is 8.08, plus sulfur, which is 32.07. We add that all up. Our total here is 68.17. Units are always grams per mole. So that is the atomic mass, or the molar mass, of ammonium sulfide. And we're all done. So if we had 1 mole of ammonium sulfide, it would weigh 68.17 grams. So H2O, you go ahead and try this one on your own, pause the video, and then come back. So for H2O, this one's a really easy one. We've got 2 H's, and we've got 1 oxygen. So we've got each hydrogen weighs 1.01, so that's 2.02 plus 16.00, and that's 16.02 grams per mole is the atomic mass of H2O, or dihydrogen monoxide. So we'll notice that whenever you add up for the molar mass of water, you're always going to get, 18.02. Just the oxygen alone weighs 18.02. And anytime you add up the molar mass for ammonium sulfide, you'll always get 68.17 grams per mole. That's how many grams are present in 1 mole. This number never changes. So how do we use this number to convert grams to moles and moles to grams? So I have a couple questions that I asked myself. So I was looking at my water bottle and I noticed that it said that there's 200 grams in there. How many moles of water is that? So that's a really valid question. So let's go ahead and solve that. So for any of these conversions, we can remember back to our triangle method that we discussed earlier, and use those formulas, or you can always start with the given, which is 200 grams in this case. And we know that this is water, so the formula for water is H2O. So we know whenever we're going from grams to how many moles, grams to moles or moles to grams, we're going to use the next step that we're going to use is our molar mass from our periodic table of the elements. And we already figured that out. That's 18.02 grams of water for every 1 mole of water. And so how do we know we put grams on the bottom? It's because when we're given grams, we want the grams on the bottom so it cancels. So after we've done this canceling, moles is going to remain on the top. And that's the units that we wanted, because we wanted how many moles given that many grams. So 200 times 1 is going to be 200. And 200 divided by 18.02 is 11.1. What? 11.1 moles of water are in my 200 gram water bottle. That is nuts. So there's no chemical reaction happening here, no balanced chemical equation, just good old-fashioned grams of water to moles of water. And to do that, we need the molar mass from the periodic table of the elements, right here. Molar mass. Okay, another question I asked myself is how many grams of our nasty stink bomb are present if we have 1.7 moles? So I did a chemical reaction. I determined that I should have 1.7 moles at the end of it. What's that going to weigh in grams? What can I put on my scale to make sure I have completed that reaction? So we're starting with what we're given, and this is given moles. Alternatively, you can use the triangle method. NH4, 2S, ammonium sulfide. And then, because we're going grams of ammonium sulfide to moles of ammonium sulfide, anytime we're going grams to moles or moles to grams, we're going to be using our molar mass. So, but this time we were given moles, so we want to put moles on the bottom here, and it's always per 1 mole of ammonium sulfide. And so if we look back up, that weighed 68.17 grams. So that number is always going to stay with the grams, 68.17 grams of ammonium sulfide for every 1 mole of ammonium sulfide. So when we take 1.7 moles times 68.17 grams per mole, we get 115.9 grams of ammonium sulfide. So if I had 1.7 moles of ammonium sulfide, that would weigh, I'd put that on my scale, and I should have out 115.9 grams. So that's pretty much it. Thank you so much for your attention. I hope this has been helpful.